In section 2.5, we discuss transformations of functions. The first types of transformations that we're going to discuss are what are called rigid transformations. Geometry class, you learned that a rigid transformation is a transformation that preserves both the size and the shape of an object. The rigid transformations that we have for functions are reflections and translations. Okay, so the first one I want to discuss is if I have that function right there, f of x, the first type of transformation I want to discuss is the one that reflects it across the y-axis. And when we talked about symmetry of functions, you should remember that, hey, the only difference between this function right here, if this is x and this is f of x, the only difference is that this one right here is that this is a negative x. So f of negative x gives me the reflection across this axis. And the way I can write it as a transformation is f of x, called my new function g of x. G of x is equal to f of negative x. The other type of reflection that we have with functions, we'll do our parabola, is the one that reflects it across the x-axis. And the only difference here is if that's x and this is f of x, the reflection gives me the negative f of x. If I call this one h of x, I can say that h of x is equal to negative of f of x. So for reflections, if I change the sign of the independent variable, I get a reflection across the y-axis. And then if I do the entire function rule and then change the sign, I get a reflection across the x-axis. Our next type of transformation is the translation, which means something moves up, down, left, or right. So we draw this graph right here. I'm going to put the typical y equals x squared up here. Call that f of x. If I want to translate this graph to the right, where this distance between here and here is some distance called h, I can take my original function and I will, if I want to translate to the right, I am going to subtract that distance h. And if I call this graph g of x, I would say g of x equals f of x minus h. So if you are subtracting a number before you perform the function rule, you're going to move to the right. I'm going to do this graph over here. I want to move it that distance. I'm going to call that one j for right now. If I want to move the graph to the left, I'm going to add before I perform the function rule. We'll call this k of x. So in this case, k of x is f of x plus the j. So if I want to move a graph to the left, I add before performing the function rule. If I want to move a graph to the right, I subtract before performing the function rule. Our last type of translation is a vertical translation. So if I take the absolute value function, and I call this f of x, and I want to move that absolute value function up a certain distance, and I call that certain distance between here and here k. I perform the absolute value function, and then I add k to each of my numbers. So again, if this is g of x, that would equal my original absolute value function plus k. If I want to move a graph up, I add after performing the function rule. If I want to move a graph down, I would subtract after performing the function rule. Combining these, you get the following generic formula for rigid transformations. A function after a transformation is equal to, we're going to put a little blank there, and we're going to discuss that, f of x minus h plus k. Where if this number has a negative sign right here, it's going to cause a reflection across the x-axis. This is right here is horizontal translation. And this number right here is my vertical translation. You should remember from when we discussed quadratics in vertex form, if my original f of x is equal to x squared, you can see that transformation, that if I have a function g of x is equal to negative x minus 3 squared plus 2, this is the same parent function, y equals x squared, that has been shifted 3 to the right because of the negative sign. It's flipped upside down, and then 2 up. So if I were to ask you to sketch a graph of this function using transformations, you are going to start with the parent function. So here's an example of graphing using transformations. The first graph that you are going to sketch would be the y equals x squared. And then we just follow the order of operations. I take my parent function and I shift it 3 to the right. So 1, 2, 3, and now it's shifted 3 to the right. And because you multiply before you add, I am now going to flip my graph upside down. So it's still shifted 3 to the right. It's reflected across the x-axis. And the final step is to move that graph up 2. So 1, 2, 3 to the right, up 2. And that would be the final scratch graph. And if I just ask you to sketch using transformations, you would be done with this graph. If I ask you to graph it using all the rules supplied in class, you would show me the series of transformations, and then you would pick smart values in to give you the 5 points for this parabola. Well, one of your values is going to be the vertex, and our vertex is at +3, +2, based off of the transformations.